There are 3 specific properties of logarithms that you will need to memorize, but they are not really all that difficult. And I don't care if you know the name of the property, you just need to know what to do. The first property is when there's multiplication inside the log. So this is log base b, and inside the log is u times v. When we have multiplication inside the log, this log will expand into log base b of u plus log base b of v. So multiplication inside the log becomes addition between the logs. Kind of like when you're multiplying things with exponents, you add the exponents. Those are very related. These properties are related. Once you know that property, you can probably guess what the quotient property is. If multiplication inside the log becomes addition between the logs, what do you suppose division inside the log is going to become? Subtraction. So log base b of u minus log base b of v. Whoa. This last property is my favorite. Inside this log, it says u to the n. There's an exponent on the u. That exponent is going to move in front, and this will become n times the log base b of u. So exponents don't stay inside logarithms. Exponents move in front. This is what makes logarithms so powerful, because if we have an x stuck in an exponent, we can take the log of both sides, that exponent comes out of the exponent and becomes a coefficient, and then we can solve. Today we are simply going to expand and condense logarithms. Expand means use these properties to take something that is just one log with a bunch of stuff inside it and split it up into a bunch of logs. I'm going to show you the way the book wants me to teach this to you, and then I will show you my shortcut. And then we will decide if we want to continue using book method or my shortcut. So the book would say, inside this log, there's this big division. And according to the properties, what does division turn into outside of the log? Subtraction. So this would split up into log base 2 of the top minus log base 2 of the bottom. Then you have to keep going until there's no multiplication or division or exponents inside the logs. So next, we would look at the fact that here we have multiplication. This is 7 times x to the third. So this one is going to split apart into log base 2 of 7 plus log base 2 of x to the third, and we still have minus log base 2 of y. Do you see anything else, particularly when you look at maybe the third property that we learned? Anything else that we could do? The exponent of 3 needs to move in front of the log. So we have log base 2 of 7 plus 3 times the log base 2 of x minus log base 2 of y. The book basically wants you to write this out step by step, almost as if you were doing a proof. Like we could write a reason next to each of these steps using the names of those properties to show why we did each step. Don't worry, I'm not going to make you actually write a proof, I promise. Okay, here's my shortcut. When I look at this original logarithm, I look at how many things do I see inside the log. And remember that 7x to the third is not one thing, it's 2 things. It's 7, x to the third, and y. So I would take my first thing, my second thing, and my third thing, and we're going to split it up among 3 logs. So I would write log base 2, a nice space, log base 2, a nice space, log base 2. Ooh, that was messy. My first thing is 7, so I'm going to put log base 2 of 7. My second thing is x to the third. Should I leave that as x to the third, or is there something else we could do with it?
Something else.
Something else, so I'd take that 3 and put it right in front. And my third thing is y. Okay, the true shortcut is, if it started out on top, it's in a positive log. If it was on the bottom, it's a negative log. So the y was on the bottom, so that log needs to be negative. Put a negative in front of the log that has y in it. 7 and x to the third were both on the top, so both of those are positive. You don't need to put a plus in front of the first one, that's just assumed. So you can look at this and split it up kind of in your mind and go straight to that last step if you want to. Or at least you could write out like this step and then this step to save yourself a little bit of time and space. All right, so do you want to do book way, showing every single stinking step, or do you want to try to skip steps? Skip steps. Number 2, how many things do you see inside the log? 3. There's 25, x to the 6th, and y. So I'm going to write 3 separate logs. Write log base 5. Leave yourself a space. Log base 5. Leave yourself a space. Log base 5. And those things are 25, x to the 6th, and y. Is there anything else we can do before we put the pluses and minuses in? The exponent of 6, you can erase the exponent of 6 from here and move it into the front. So this is 6 times the log base 5 of x. Okay. 25 was on the top, so that log needs to be positive. It is. X to the 6th was on the top, so that log needs to be positive, so put a plus in front of that log. And what symbol do you think we should use in front of the y?
Negative.
Positive. Do you see anything on the bottom of this original log? No. All right. Number 3 is a little bit longer. You might have to kind of extend, like under here. You might have to extend your space like this. I would like you to try number 3 on your own. So pause the video, try number 3 on your own. So inside this log, I see 4 things: 9, y, 1000, and x squared. So I've got 4 logs. Notice that there is no base shown. That means it's base 10 and you don't have to write it in. So log 9, log y, log 1000, log x squared. We can take the square on that x and put it in front. 9 and y are on the top. So log of 9 needs to be positive. Log of y needs to be positive. 1000 and x squared were on the bottom, so those logs both need to be negative. If you want to be super picky, 1000 is actually 10 to the third, so that would be 3 times the log of 10, which is actually just 3. So right there it should be minus 3, but I'm not going to be that picky, at least not right now. So if you have what I have boxed as your answer, you are good to go. Okay, everything that we do in math, there's a way to undo it, reverse it. So if we can take these properties and take one log and expand it out to a bunch, we can take a string of logs and condense them back. The important thing is that all of the logs must have the same base in order to condense them. So using the shortcut kind of in reverse, the first thing I always look for is numbers in front of the log. So do you see that middle log? It says 2 times the log of 2. So that one was originally 2 squared. You can take that 2 and put it back as an exponent, and then you can finish condensing. I'm going to write 1 log, and because there is a subtraction sign, I know that there's going to be a top and a bottom inside the log. Log of 6, that one's positive, so 6 goes on the top. Log of 2 squared, that log is positive, so times 2 squared goes on the top. The log of 3 is negative, so 3 is going to go on the bottom. So we have the log base 10 of 6 times 2 squared divided by 3. If you were doing this for an online assignment, you would actually multiply 6 times 2 squared and then divide it by 3. But we're not doing this for an online assignment, so that's good enough for right now. Do you feel like you could try number 5 on your own? Try number 5 on your own. Pause the video, give it a try. The first thing, the 2 in front goes back as a square, so that's 7 squared. The 5 goes back as an exponent, that becomes x to the 5th. 7 squared, that's going to go on top, and I don't care if you write 7 squared or if you write 49. And on the bottom, x to the 5th. X to the 5th comes from a log that was negative, so that one goes on the bottom. So technically your final answer would be log base 3 of 49 over x to the 5th. Have you tried 6 on your own yet? Go for it. Pause the video, try number 6. Okay, first take all of the numbers in front and move those back to exponents. Then we've got the log base 8. X squared comes from a positive log, so x squared is on the top. 5 comes from a negative log, so 5 is on the bottom. Y to the 3rd comes from a negative log, so y to the 3rd is also on the bottom. And that would be your final condensed answer.